If I was to wire a socket outlet in the kitchen, I would consider these three important facts. Number one, the size of the cable that is supplying that socket outlet with current. And number two, the circuit breaker that serves that socket in the consumer unit. And number three, the type of the socket has to be a twin socket, and also it must be a quality socket that can be able to handle large currents. Now, if you're getting value out of this video, kindly smash the like button. Home electrical and electronic appliances that we use in the kitchen normally draw a lot of current, and for this reason, the socket must be able to handle that large current. So now let us go ahead and wire these sockets. It is important to note here that I left a good allowance for the cables for future repairs. So this is the twin sockets. Just remove the wrapper, and upon removing it, we notice two earthing connection. One is here, the other one is here. We have a neutral connection which will serve both the outlets, and then we have a live connection which is one, which will also serve both the outlets. One earthing will only unscrew that. That way, and then we go to the live or the face connection. We'll be connecting our live there. So we also unscrew it like that. Then we go to the neutral and we also unscrew it like that. So there we have it. Now another important thing to take note is the size of the cable. The size of the cable for this case here is 4.0 millimeter square. That is the cross-sectional area of the wires that are here. Another important thing to note also is the insulation. It is thick and quality and can be able to handle the current that is going through these cables. So we go ahead and strip. So that is back folding. Again, for my neutral, the neutral wire in this case is a black wire. So this is according to our country, but for your country or your region, you might be using a different color code. You have to adhere to that when you are getting your cables or your wires. So there we have it. We have the live, or we have the face, and then we have the neutral and the earth. Now coming to our twin socket here, the live, which is the red, will go to L. Can start with that and make sure as we connect it that it will go all the way in and not leave an insulation. Number one, our connection must not you see, it has to go all the way in and no wires should be seen. Another consideration is to ensure that that screw there will only screw the wires and not this insulation, because once it screws the insulation, there will be a problem because the appliances will strain to get current. So I have ensured that the screw will screw the wire, and then I have to do that. So there I go, to ensure that it is tight so that it will be able to conduct the current properly. And then I go to the neutral. The neutral, I will still do the same. I will now connect it there and insert it. Just connect it there and ensure that all the wires are inside. And before I can actually screw, another important thing is to ensure that I do not insert it so much inside so that it will now screw the insulation. So there I have it, as if you're able to see. So I can just go ahead and screw it. Now finally we go to the most important wire that I consider in this entire connection, which is the earthing connection. Remember, in the kitchen there are a lot of appliances that are metallic in nature or have a metallic surface, so this connection is very important. So we connect it there, and just like other connections that we have done, ensure that the wire gets inside properly. And again, to ensure that once I start screwing, it will not screw the insulation, but it will screw all the wires properly there. So the screw I have to check, don't know whether you can see, but I've confirmed that the screw will only screw the wires. So I'll go ahead and screw it and ensure that it is mechanically sound. So all my wires, I will have to fold them inside so that in future, if there will be any repairs needed, I have left an allowance there. So finally, we have our socket. Now the next step is to wire our circuit breaker or the MCB. Important to note is that this MCB has to be rated at 32 amperes. That is the minimum rate that we can have for this socket. Mind you, the customer or the user may decide to have a microwave on one plug here and also have an extension cord on this, where they might connect several other appliances which equally draw a lot of current, and all that will come along through these wires and will be fed by this circuit breaker or the miniature circuit breaker. So it is important for us to consider all those factors, and for that we definitely have to use a 32 MCB. If all of those appliances will be connected at the same time, then it means anything lower than a 32 ampere MCB will not be able to handle that current. We are assuming the worst case scenario, where in the event that the user will connect all these appliances, this MCB will comfortably handle that load. Now, in the next video, I will be wiring the normal socket that we do have, where we connect appliances that don't draw a lot of current. Again, I will be talking about some of the mistakes that we do when connecting those sockets as electrical technician. I will go further into explaining about other methods of connecting these sockets, as well as the circuit breakers that will be used and the wire size. See you in the next one, but in the meantime, subscribe to my channel.